All right. So, good morning, everyone, and also from my side, welcome to the CNS Munich. It's really good to see the community growing and also so active these days, especially also in Germany. It's very important also for me, to my heart. A big thank you, first of all, to the organizers. It's really great that you make this happen again, and congrats to your 5th anniversary. So whether you're a regular or a new one to the CNS, it's one of the best rooms to meet like-minded people and also just to get started with cloud native. But of course also with AI, so you will see and hear a lot of AI talks today as well. My name is Julian Hennig. I'm Advisory Solutions Architect for Cloud Native at Nutanix. And since this is one of the first talks today, or the first talk today, we already did a little bit of stretching, but perhaps we just do it again. So hands up, who's using AI frequently? Yeah, almost everyone. Who's actually running artificial intelligence, so operating it yourself? Yeah, only a few. And of those who are running artificial intelligence, who's using a cloud offering? A few, okay. And who's running artificial intelligence in their own data center or on premises? Also, just a few. Enough stretching. So it's always interesting on the one side to also see where the community currently is in their journey, of course, towards running modern workloads today. And of course, one of the biggest drivers for sovereign AI or for artificial intelligence in on-premises data centers is definitely digital sovereignty and costs. But also, we need to find the best ways to support our businesses to run modern workloads, as mentioned. So these drivers push almost everyone towards one question: how do we become more self-contained? Not only from a technical point of view, perhaps also from a business or organizational point of view. So today, I want to talk on a fear that I hear a lot, especially from people that are more infrastructure focused. So is AI so special that we should be afraid of running it ourselves? The clear answer from my point of view is no, because the Kubernetes community, and especially anyone with Kubernetes knowledge, knows that it's just another workload. Artificial intelligence has different requirements, but at the end, just another workload. And I'm going to show you why today. So the fear underneath a lot of the let's just use the cloud for artificial intelligence workloads, decisions. This fear is AI too new to run it ourselves? Too new, too magical, too fast-moving, or especially for the platforms that we already know how to build. But here's the thing: if that fear is true, then of course going for the cloud or going cloud only for any artificial intelligence workloads is a perfectly rational decision. Let someone else who already solved it carry it for you. But if it's not true, if AI is mostly made of problems that we already know how to solve, then we have everything that we need to run it ourselves. Oh, sorry. So the question is it true? And of course, I'm going to show you that not with a slide full of CNCF logos. I'm going to show you that with one concrete problem. An enterprise actually hits when it goes for an AI native platform. But first, let's be clear about where workloads are already running. You already saw the picture. So Kubernetes already won the artificial intelligence platform championships. By the way, this was generated by Flux2 from Black Forest Labs from Germany. So if we zoom out, among container users, Kubernetes went from 66% in 2023 to 82% in 2025. CNCF's own words for that is boring. And boring is the highest price in, of course, infrastructure. So Kubernetes won the game. If we step back from the hype from artificial intelligence, or see where artificial intelligence workloads are already running, the CNCF annual report put a number on this, which is 66% of artificial intelligence or of organizations that are running artificial intelligence workloads already in Kubernetes. And it's not measured, or it is measured rollout, so no hype. 23% of those 66% already full adoption, and 43% are partial adoption. So people doing this deliberately, infrastructure first. And the ecosystem, of course, also moved with it. So tooling from the CNCF like Kaiser, VLLM for gateway, Envoy gateway, or Istio, but also routing with the gateway API inference extension. On the other hand, also, of course, from an observability point of view, with OpenTelemetry, Cert Manager, but also vector databases and Docklink, for example. But it's not only, of course, the CNCF, it's also growth in the AI and data foundation, and also the recent formation of the Agentic AI Foundation. So there's a lot of moving parts already in the direction of artificial intelligence. So the substrate already exists. So the platform you would build sovereign AI on is Kubernetes. And it's the one that you already operate or plan to operate. Hopefully you already operated. So if the substrate is here, why isn't everyone doing it? That's definitely attention. And here it is. Artificial intelligence workloads are moving faster or evolve faster than enterprises can stand up a platform to support them. That's also the reason, of course, why a lot of you are moving towards a cloud offering. So when you add data sovereignty or sovereignty and data constraints on top, keep the data here and also control where inference runs, it even gets harder. So at the end, people are throwing up their hands and go cloud only. I want to show you 3 challenges that we hear and see very often. One is, of course, change. Again, pace is brutal. Just take the RAG versus long context window debate. As context windows grow, do you still need to have RAG pipelines? Or just does the model just swallow the documents and that's it? And of course, with those requirements, the whole platform changes underneath, or the requirements for the platform change. So definitely a big problem. Second one is gateway. Gateway, of course, is interesting or is very important because you want to have one gateway, one control point to do your monitoring, routing, but also cost and policy management of any model that you want to run. Doesn't matter if it is a model you want to run inside of your data center or if it is a model or an AI offering, a cloud offering that you want to control. So in the best case, you have one control point and the platform behind it matures, but the gateway stays the same. And one of the most important ones, of course, is standards. So OpenAI formatted requests, also talking to open APIs, it's very important. So you can swap models and vendors as needed. That's what keeps you portable, of course, and portability is what keeps you sovereign. So the question becomes concrete. When an enterprise tries to build an AI platform itself on Kubernetes, what do they run into? So some brand new AI-shaped problem that you've never seen before that justifies giving up, or is it something that we already know? Let's look at exactly one. If we forget about AI for a second, I've got a service where every request carries a big chunk of state. Processing that state is the expensive part. The same state shows up across many requests, and my load balancer is stateless, so it sends anything to whoever's free, and does completely ignore which node has this relevant state warm. If I describe you that over coffee, for example, with the barista coffee on the first floor, you would definitely know exactly what to do. Cache it, route it by locality, keep the state where it already is. That problem that I just described is LLM inference. So the KV cache is basically the state, and the expensive part is the re-encoding of a long prompt. Cache it, of course, is a problem with our gateways and also our load balancers. So basically, if we strip away the whole AI vocabulary, it is state, data locality, and routing. That's the biggest problem. It's not a new beast, it's a beast that's wearing a GPU. There are three resulting issues, of course, with this problem. Of course, we are wasting GPU compute. So re-encoding every request again and again is wasting any resources. And this re-encoding, of course, makes our time to first token climb and brings us higher latency. But also a cache-blind load balancer will send work where data isn't. So if that is an old problem, and we already know how to solve it, let's have a look at the answer for LLM's inference and what it's actually worth. The answer is called KV cache-aware routing. So the KV cache is the model's working memory for a given context. If a worker already has processed a long prefix, say the same big document in your RAG pipeline or a system prompt, for example, that work is already sitting warm in the GPU cache. So instead of blindly load balancing, you route the next request, of course, that needs that prefix to the worker that already has the relevant state warm. So the request comes in, again, through our AI gateway, for example, Envoy AI gateway fronted by Istio, and hands the routing to an endpoint picker, EPP. It's a gateway API inference extension, and this piece does exactly what we talked about. So it knows which worker has the relevant state warm, and skips, of course, re-encoding it. At the end, we have our worker, and this worker can run on VLLM, on Kserve, for example, so it does not re-encode what we already encoded. And if you notice, every piece or every box of this is open source. Envoy AI Gateway, EPP, Kserve, VLLM, Istio, but also supporting components like, again, OpenTelemetry, Cert Manager in the background, and others, all open source. So it's not a vendor secret sauce, it's the communities. So for Serenity, the most important part is that your vendor ships exactly on these premises or primitives. So you can be sure that switching sites is easy and doesn't require a lot of rewiring, basically. That's the whole point. So let's take a look at the results. 4.3 seconds to 0.6 seconds. That's the time to first token on a 10,000 token prompt. The second time it is served. Same GPU, same model. The only difference is we didn't recompute what we already computed. That's KV cache reuse, measured on LLMD and VLLM. And here's the catch. And that's also the whole reason why routing matters. If you do that with a cache-blind load balancer, of course, spreading traffic round robin, it would miss the warm cache about 3 out of 4 times. And of course, if you have 4 nodes, that's 75% of the time. You bought the GPU, you also have the cache, but you throw away the win just because you have a cache-blind load balancer. So caching is the price, and cache-aware routing, the endpoint picker, is how you actually win it. And every piece, again, is open source. So how do you get this into your cluster, and how do you use the endpoint picker, for example? And that is a new term, basically, endpoint picker for most of you. But it's also newer than most things in this room here, for example. So it's really, really new. But the reassuring part, it's not a new paradigm. It's an official Gateway API inference extension. So it is nothing new. It is coming from the Kubernetes community and also part or was worked on by the special interest group network. So basically, there are 3 components. One is, of course, the inference pool. It's a CRD, custom resource definition, and you can think about it as a Kubernetes service, basically, but inference aware. So it groups your models, or groups your model server pods into a pool, so platform owners can manage that pool, and the app owners just send requests to it. Next, we have the endpoint picker, the EPP. And that is the piece that does the magic in the background. So for each request, it picks the best pod using live metrics from the model servers. So also KV cache utilization, queue depth, active LoRa adapters, all of that is being measured. So at the end, it's not magic, it's metrics-based scheduling, nothing else. And we have the body-based router, the BBR, which is also very interesting because every request that is OpenAI formatted can have the model's name already in the request body. So the BBR will send exactly this request to the model that needs to be allocated, basically. That's the OpenAI format standard paying off. Because it's community standard, it's not one secret vendor secret sauce. Of course, all of these open source tools use the same EPP protocol. So Envoy AI Gateway, Istio, Nginx Gateway Fabric, or Agent Gateway. All of them have one standard, and that is the EPP. So again, this gives you portability, and portability is what keeps you sovereign. So again, let's step back. What's the lesson here? The boring distributed system answer usually wins. And that is why this community is so well positioned. And KV cache aware routing is just state aware routing. So it's nothing new, it's not magic, it's data locality and cache aware routing. You've been doing that for a decade. So it's a known shape, basically, and the proof that AI isn't scary because it's a known problem. Again, distributed system challenge, not something new. A practical one, of course, from real deployments, keep vanilla baselines. When something's slow in production, a lot of people blame the model or the GPU, for example. but it's most of the time something boring underneath. So I've seen a model performance, for example, or model performance issue, which was basically just a configuration pool or configuration issue with a pool for storage. So basically, a lot of people are blaming different things, different wrong things, than just looking at the baseline instead and finding the issue much faster. But I also want to be straight with you. Getting this up and running is the easy part. Where most teams hit the wall is day 2 operations. So GPU lifecycle management, multi-tenancy, but also optimized resource utilization or storage for model weights at scale. So that is definitely a longer conversation, and I have 25 minutes today. But again, it's not magic, they are solvable, and especially with a good partner who can help. So open standards, especially in combination with GitOps, are giving you a true sovereignty strategy here. Kubernetes as near as to open upstream or open source upstream as possible. And the best case, of course, no fork. And GitOps where you can. That's giving you a lot of freedom from the beginning. I also work with enterprises that exactly build their platform and strategy based on these primitives, and they were able to switch sides within days, not weeks or months. So keep open standards at the center. So AI isn't scary for this community. It's just the next distributed systems problem, and we've been solving those for decades. You saw it this morning. The answer wasn't magic, it was cache locality and state-aware routing. Boring? No. And you can be sure that the next distributed system problem is already around the corner, and the community will solve that one too, I'm pretty sure. So the question was never if you can build sovereign AI on Kubernetes, you can. The only answer or only question is whether you will wait for someone to sell it to you, or if you do it yourself. So that's it from me. What matters the most is definitely the question that we opened up with. So how do we support our businesses and ourselves for AI workloads now and in the future? This event is definitely the best place to find solutions and partners. And the example that I showed you today turned out we are solving a problem that we already solved before. So most of them are just distributed system problems or challenges, so the choice is yours. Do you want to work on them, or do you want to have someone else hand you a solution that already solved them for you and keep supporting you as requirements change? Either way, I'm hoping to see you at the event later today. Again, for great conversations, come find me, especially if you want to talk day 2 reality. So thank you and enjoy the event.